Greetings to everybody. Today, we will discuss critical thinking and problem-solving skills, which are crucial in the fields of electronics. These abilities are critical for repairing and enhancing circuits, which improves functionality. The title of the project is Circuit Mastery, Problem-Solving and Critical Thinking in Electronics. This video will cover the three topics. First, how to recognize circuit issues. Second, troubleshooting approaches. And third, how to test our remedies to ensure flawless operation. Let me present our incredible crew to collaborate on this project before we get started. Alger Diaz and Micah Mendoza concentrated on research and figuring out typical circuit issues. Janessa Paz, they show how to solve problems and how to troubleshoot them. Aris Tañedo, they manage the assessment procedure, ensuring the efficacy of the solutions. Elsie Madrid, for this film, I work on connecting the dots and presenting the idea to provide you with this fascinating and educational initiative. We shall pull our talents. Moving now begins without further ado. Part 1. This is where we start our video. Electronics problem-solving techniques by taking through a typical issue scenario. We'll show you how to construct and troubleshoot a basic circuit.
We start by determining the issue. The LED isn't lighting up in this instance. This indicates that there is a problem with the circuit. So let's investigate the issue.
Step 3. Test components. A multimeter will now be used to test the components. First, let's check that the power source is providing the appropriate voltage. Power supply is in good condition because the voltage is correct. Let's then use the continuity mode on the multimeter to examine the lead. If the LED doesn't pass the test, we know that is the problem.
Now let's move on to step 4, which is the troubleshooting fix. Since the lid is broken in our situation, we will swap it out for a new one. Let us now rejoin everything and perform another circuit test. Now we are off. Now that the LED is functioning flawlessly, these procedures have allowed us to successfully identify and solve the issue. In section 2, using the critical thinking in circuit design, LC, after talking about troubleshooting, let's discuss how to use critical thinking in circuit design. This section will consider ways to enhance or alter a light-sensitive circuit. Simple electronics like project. After discussing troubleshooting, let's discuss how to use critical thinking in circuit design. In this section, we will consider ways to enhance or alter light-sensitive circuit, which is a simple electronics project.
Step 1. Questioning. So let's challenge a few presumptions first. We're utilizing a particular kind of resistor. For instance, but is there a better option? We selected this specific light sensor for what reason? For our project, it is the best choice.
By questioning these presumptions, we expose ourselves to fresh ideas that may result in increased effectiveness or performance.
Step 2. Analysis of scenarios. Explain experimenting with the circuit by varying the resistor values, attempting a different light sensor, or modifying other components. Next, let's analyze some scenarios. What happens if we change the resistor value? Or what if we use a different light sensor? Let's test this modification and see how they affect the circuit's performance. For instance, we may alter the circuit's response time by increasing the current by
evaluate the solutions. Here's a side-by-side comparison of the original design and the modified version. In step 3, evaluating solutions, it shows the before and after comparison of the circuit performance.
Step 1. Evaluation and group discussion. We must determine which circuit version is the most efficient after testing various parts and configurations. Thus, updated design actually solve the problems we found before, such as lowering power usage or speeding up response time.
It is of maintenance and assembly must also be taken into account. Beginners will find it more difficult to troubleshoot a circuit that is more sophisticated later on. Next, let's analyze some scenarios. What happens if we change the resistor value? Or what if we use a different light sensor? Let's test this modification and see how they affect the circuit's performance. For examples, by lowering the resistance, we might increase the current. We could change the response time of the circuit.
Great points. It's clear that we need to balance performance, ease of use, and cost. Now let's look at the results from all our tests to finalize our decisions.
Again, in step 3, the evaluating solutions. This showed the before and after comparison of the circuit performance. Looking at the results, the modified design has a faster response time, but there is a trade-off. It consumes more power, which might not be ideal for the power or battery-powered applications.
Applying critical thinking, as you can see, aids in both improving circuit designs and comprehending the traits of involved in every choice. This process includes analyzing solutions, testing strategies, learning from mistakes. We make a wiser decisions and produce more effective designs when we exercise a critical thinking, team collaboration, and decision making. Now, let's wrap by looking at how we work together as a team to make the final design decision. In this part, we'll show how we evaluate circuit modifications and came to a conclusions on which design was the best.
Step 1. Group discussion and evaluation. After experimenting with various parts and setups, we must determine which circuit version works best. Does the updated design actually solve the problems or previously found, such as enhancing response time or cutting down on power usage?
We also need to consider how easy it is to assemble and maintain. To more complex the circuit, the harder it will be for beginners to troubleshoot later.
Fantastic points! It is obvious that cost, usability, and performance must all be balanced. Let's now review the outcome of each to make us a final conclusion.
Step 2. Final design presentation. We've determined that the improved design, which includes a more effective light sensor and a lower resistance resistor, it is the best choice for after testing and discussion by accelerating the circuit while maintaining a manageable power consumption. It enhances its performance.
To lower the possibility of failure, we also pick a more dependable component of simplified the connections. The original issue is successfully resolved by this design, which also facilitates construction.
In the end, our final design not only works better, but it's also more efficient and easier to build. The collaboration and decision-making process taught us how important it is to share ideas, test different approaches, and rely on each other's strengths.
As we wrap this video, let's quickly recap the key and techniques we use in problem solving and critical thinking throughout the project. In order to test the solutions, we first recognized the circuit issues and took a methodological approach to solve them. The optimum design was determined by testing different scenarios, challenging component assumptions, and assessing our responses. Reflection in groups, final montage of the teamwork, including the circuit functioning successfully and the team celebrating.
I discovered how crucial it is to consider our choices carefully. The best solution isn't always the most obvious. It really opened my eyes to test various parts and observe how minor adjustments impact the circuit. It made me realize how important experimentation is. I learned from working as a team that when we share ideas and cooperate, we can solve difficulties more quickly. Everybody has something worthwhile to contribute.
Critical thinking and problem-solving skills are crucial for innovation and successful initiatives in electronics industry. We may address problems more skillfully and provide innovative solutions by putting these abilities to use.
We appreciate your interest in our video. It is our hope that you have acquired some useful knowledge about design, optimization, troubleshooting, and the significance of collaboration in electronics projects.